So in this exercise, again, simplifying radicals, we're going to combine what we've learned about simplifying numerical radicals and simplifying radicals involving variables. So in this first problem, we're looking at part A, the square root of 64x squared. So again, we're looking for perfect squares. When we have a product between a real number and typically a whole number and a variable to an exponent, we want to look at them as a unit. So in other words, the numerical value being squared and the variable value being squared. In this first instance, we would recognize 8 squared equals 64, and obviously x squared equals x squared, so this is going to equal the square root of our perfect square is going to be 8x all being squared, because you square the 8, you square the x, you get 64x squared. And what we need to recognize again goes right back to the same rule we had before. We have an even index, this invisible 2 that's out here, and we have an even power. In this case, it's just being squared. But what that means is that we need to take the absolute value, because we have an even index and an even power for what's underneath the radical. In that case, in other words, remember this is the nth root of a to the n. If n is even, then that means that we have to use the absolute value. If n is odd, then that means no absolute value. So in this case, we have an even root, even index, and we're taking it to our perfect square. It's being squared, so we have to use the absolute value. That said, we know our 8 is positive, so we don't need to have it in the absolute value. It would be on the outside. 8 times the absolute value of x. And you could just as easily say that, put an interim step in here, that this equals the absolute value of 8x, but then that's just going to equal 8 times the absolute value of x, because again, we know the 8 is positive. So the square root of 64x squared equals 8 times the absolute value of x. And with the part B, we're taking the square root, but again, remember this negative sign is outside the radical, so that's perfectly fine. Let's first look at 100. We should recognize that 10 squared equals 100. So then this becomes, don't lose the negative, this becomes the negative square root of 10p being squared. And same situation as part A, and that we do need our absolute value because it's an even index, the square root, and it's an even power. We're taking it to the power of 2. So n is even, that means we need the absolute value. Let's go ahead and put in the step we skipped in the first part. So this would be negative absolute value of 10p. We know 10 is positive, so this is going to be negative 10 times the absolute value of p.